Assalamu alaikum wa rahmatullahi wa barakatuh. Yeah, once again, welcome to online physics class. So, inshallah, today we will be looking into fluid at rest and in motion. So, under fluid at rest and in motion, we have the subtopic of surface tension, application of surface tension, reduction of surface tension, angle of contact, and the likes. So, when we refer to a fluid, we refer to either liquid or a gas. Now, solid is not being regarded as a fluid because of the intermolecular forces of solid are being held together. So that means that the molecules of solid are held together by intermolecular forces. So they are not free to move. So basically, is that when we refer to a fluid, we are referring to either liquid or a gas. Now, so when a fluid, when they are at rest, that is, they are not in motion, we have two intermolecular forces acting on them, and the two intermolecular forces are, we have the first one, we have cohesive force, then the second one is we have adhesive force. So these two forces are the forces acting on a fluid that is being at rest. No, so what do we mean by cohesive force or an adhesive force? A cohesive force is a force between molecules of the same substances, while adhesive force is a force acting between molecules of different substances. Practically, when we have a glass containing water, you will be seeing that along the glass there are some molecules of water on that glass. So that means that a water wet glass, because that the adhesive force acting between the molecules is greater than the cohesive force. So for example, so that is why that water wet glass, because that the adhesive force acting between the molecules of water and the glass is greater than the cohesive force. So if, for example, if you have a mercury, instead of mercury to wet a glass, it forms a globus. It forms globus on the glass. So instead of mercury to wet a glass, it forms globus. So that means that we now say that cohesive force acting between the mercury is greater than the adhesive force. So these two forces are the forces acting on a fluid that is being at rest. And mind you, the study of a fluid at rest is being referred to as rheology. Please take note. The study of the liquid at rest is being termed as rheology. So, and we have the two forces acting on them, cohesive force and adhesive force. Now, so once you add of a fluid, now you know what we refer to a fluid, which is either liquid or gaseous substance. So solid is not being termed as a fluid. Now, so let us now go to the business of the day. Now, the first thing we have here, we have surface tension. Now, you will be seeing that in some experiments, when we see a water, it behaves that they are having an stress elastic, they are as like a stress elastic skin. Now, for example, when you gently open a tap, you will be seeing that the water, as they are gushing out from the tap, they will be forming a layer as if that it is a skin. Okay, so you can try that out. So once you gently open a tap, layers of water will be coming, or water will be flowing as if that they are acting as a skin. So that phenomenon is being termed as a surface tension. Now, basically is that tension of the surface is being referred to as a surface tension. So when a surface possesses a tension, so we term it as a surface tension. So physically, or how do we define a surface tension? So surface tension can be defined as the force acting on the surface, that is the force per unit length acting on the surface of a substance. So we say that surface tension S dot P equals to force per unit length, that is force over length. So this stands for the formula or mathematical relation for calculating surface tension: the force then divided by the length. So we all know that the unit of force initially, which is a Newton, while length is a meter. So therefore we can say that the unit of surface tension is a Newton per meter. Please take note, and this unit, it will be a derived quantity, not fundamental quantity. It is called a derived quantity. Now, aside of this one, you will be see that it is okay. You can see that when there is raining, so if you don't want to be drenched by a rain, you use an umbrella, right? Now, so what umbrellas do is that they use the phenomenon of surface tension to provide a material to coat that umbrella you are using, so that water will not be able to penetrate through the material. So that this is one of the applications of surface tension that they are using in a waterproofing material, that is in the production of waterproof material or waterproof or rainproof substances like your umbrella. So once you on your umbrella now, you will see that you will not be drenched by the rain, because that as the rain fall, it will be retaliating the rainfall, so that what we have, you are inside the umbrella will not be able to drench by the rain. So this is one of the application of a surface tension. Another thing, application of surface tension is that you will see that there are some insects, they are able to walk on a sea or on a river. So that means that as they are walking now, these layers of the water will possesses a surface that it will seem as an elastic skin, so that water some insect like water snake, so they can be able to walk on a water surface without being drawn into the water. So this is one of the application of a surface tension. Now, so basically is that when surface tension occurs, it has some application, and which is one of it is that in the production or in the manufacture of the waterproof or rainproof material. So, and also some insects are able to walk on a water surface. Another one is that also in the soap and detergent, you will see that once you are washing something, it forms bubble. Okay, that bubbles formed will be acting as a surface tension, whereby that after you pour a detergent on the surface, you will see that for a little while the water will not be able to flow on, the bubble settles down. Okay, so that means that it is until the bubbles has been cleared that water will be able to move as is being usual. Okay, so this is one of the application of a surface tension as well. And so then how can we reduce surface tension? Surface tension can be reduced by some of the following. Now we have the first one is that by boiling the liquid. Now, so if you boil the water, gradually the surface tension acting on that surface is going to reduce. Then another one is that by adding of a detergent or soap. Then another one is that by adding oil. Okay, you will see that once you add an oil, so the surface tension of that liquid is going to reduce. Then another method of reducing surface tension is by using an alcohol. So once you apply an alcohol to a liquid surfaces, the surface tension of that liquid is going to gradually reduce. Then another one is also by using of kerosene. So if you apply a kerosene to the liquid, likewise the surface tension is going to reduce as well. And likewise if you use grease, so grease also reduces the surface tension of a liquid. Now, so we have now talked about surface tension now, application, reduction, and then Now, angle of contact. What do we mean by angle of contact? You will be seeing that if you use a place to it, particularly that the soup contain much oil, if you want to wash that plate, it's going to give you more challenging. You have to add more detergent before it can be properly washed, right? Now, that means that there is something, okay, ordinarily if you use water and oil to wash a plate, it will not be washed, okay, until you add a detergent, right? Now, that means that there is an angle of contact between that place and the oil. So until that angle of contact is being decreases to 0, definitely what you are doing is you will not be able to perform that task until that angle of contact is being erased. For example, now let me draw, okay, let's take a look into these surfaces now. Let's assume that we pour water in a glass cup. This is our water now. So this is water. You have water here. So this is what. Now you will see that we have too many meniscus acting. Two type of meniscus. Is either we have what we call concave meniscus, and we also have convex meniscus. Now, when the meniscus of a substance is bent inward, that means that it is a concave. You can see now. You can see the meniscus now. This is what we call meniscus. This thing now, this is called meniscus. So this is our liquid now. So this is how this is how the shape of water looks when you pour it inside a container. So we have water here. So the kind of meniscus of water is called concave meniscus. Please take note. And if it is a mercury, now, so let's assume that mercury have fine surfaces now. So meniscus of a mercury, it is a convex because the meniscus curve outward. This one curve inward. You can see it's curved inward. So this is what we call concave meniscus, and this is called convex meniscus. So this is a mercury. So this is a mercury now. So you can see that now. How do we now determine the angle now? The shape of that meniscus, the angle it made with the glass container. So that from here to here is called the angle of contact. Let me denote it as a Q. So this is our or theta. Let's use theta rather. So this is our angle of contact. So for example, now you have a glass or you are washing a plate having much oil, so it is until this angle of contact is being able to decrease to 0, then that is when you can have a perfect or clean glass container. So what you do here is that is when you try to add a detergent. So the function of a detergent is that it makes the angle of contact acting between the meniscus of the water and the glass container to decrease to 0. So once it's able to decrease the angle of contact between here to 0, then that plate or the glass cover would have been clean. Okay, so this is what we define as angle of contact. That is the angle between the meniscus and the container of that the liquid inside the glass cup or any other container. So here for the mercury now. For the mercury, so we have the angle of contact here. This is the angle of contact now. So this is angle between the container here and the normal line you are able to draw along the meniscus. So this is the angle of contact for mercury, and you can see from here that in the meniscus of water, the angle of contact here it will be between 0 to 90 degree. That is an acute angle is formed. But here for the mercury, you can see that this is an obtuse angle. So it will be between 90 then to 180 degree. So now, so that means that the angle of contact between in the meniscus of water is between 0 and 90 degrees, while that of the mercury is between 90 and 180. Please take note of this. These are some of the phenomena that physics are able to physics are able to explain through some ideas that okay. And then now, if you will see that if you still boil the water, you add just a little quantity of detergent to clean that container, unlike if the water is cold. Okay, so that means that a cold water also possesses more angle of contact than a hot water. You will see that once you boil the water a little bit, then add just a little quantity of detergent, gradually what you are doing will have been done. That is, the plate will have been clean, right? That means that cold water possesses more angle of contact than hot water. So likewise, there are some things that you should be doing. If you have a place to wash, just boil a little water, then add a little detergent instead of finding a cold water and you use much of your detergent. Okay, so this is one of the techniques that you can apply to save your money. Okay, so this is what we call angle of contact. That is the angle between the meniscus of that liquid and then the glass container. So and it varies. It's either between 0 to 90 degree or to between 90 to 100. So these are some of the applications of a surface tension. So mind you, as we have stated, we stated that surface tension can be termed as the tension of a solid, that is the force acting on a liquid to make it behave as an elastic skin. That is, you will see that it will be forming as if an elastic layer. You will see that once you gradually open a tap, this is a tap, you just open, so water will be forming like this. Okay, so this layer, they will be here, this layer will be acting as if they are a elastic skin. Okay, so that means nothing will be able to pass through it just like that. Okay, so they will be acting. You will see as water is gushing out, it will be gushing in form of this shape. So making it to behave as an elastic skin is termed as a surface tension, and it has so many applications as you have stated. And likewise, mathematically it can be given as surface tension is defined as the force per unit length acting on the surface of a liquid, and the unit is being given as Newton per meter. I think you all get that now. So let's take this example now. Example one. So we have that calculate the force required to lift a needle. Calculate the force. F equals to unknown, right? Now, of length 4 centimeter, we have our length equals to 4 centimeter. Log of water. If the surface tension F dot T equals to 7.3 exponential minus 2 Newton per meter. Now, so we are asked to calculate the force. So we are given the length and we are given the surface tension. So what you have to do here is that recollect the formula for finding surface tension, which is a surface tension equals to force per unit length, right? Now, so if you make F the subject of the formula, we have that our F equals to surface tension times length. Now, but you will see that in physics we do express our unit in SI unit, that is standard international. Please, all parameters you are given has to be expressed in their SI unit. So the SI unit of length is a meter, the SI unit of mass is a kilogram, the SI unit of force is a Newton, so and some other things like that. So you have to know their SI unit so that this one has to be converted to meter. Okay, now so that means that if you want to convert 4 centimeter to meter, what do we do is that this will give us a 0.04 meter. Okay, now that is you divide by 100 or you multiply by 10 times 10 raised to exponential minus 2 meter, because as you have taken sub quantities in the first term, that cents means 10 raised to power minus 2, hecto, and all those things we have treated that. So you can refer to your notes. What do you mean by deca? What do we mean by micro? What do we mean by milli? And the likes. So that means that 4 centimeter equals to 0.04 meter. So by substituting our value, we have 7.3 exponential minus 2 multiply Newton per meter. So you can leave Newton per meter multiplied by length 0.04 meter. So from my calculation now here, the final answer I got here is the force equals to 2.92 exponential minus 3 Newton. So please take note. Surface tension is being given mathematically as a force per unit length acting on the surface of a liquid. I hope it is very very clear to every one of you. So likewise, among the other applications of surface tension is that we have a nib of old-fashioned pen and the like. So all those things, you have a comprehensive information on when you have your notes, as I will do send that to you online as well. So this is what I have for you today. When you refer to a fluid refers to either liquid or a gas, and the study of liquid at rest is called the study of flow of liquid is called rheology. The study of flow of liquid is called rheology. So and then the phenomenon making the surface of a liquid to act as if it is an elastic skin is called surface tension, and it has so many applications. You can also Google search many of the applications aside of what you have been given here. So you will see that it is very great to know more of these applications. So because as you have your umbrella, this is a rainy season now. Many of you will be coming to school inshallah when we resume with your umbrellas, right? So what you are doing is that you are using one of the techniques of surface tension, which is that the material of the umbrella has been coated with a material that will not allow water to penetrate through it, that it will act as if it is an elastic skin. So we have many other things as well. You will see the canopies as well. If you are inside the canopy, you will not be able to drench by the rain. So that means that the canopy as well has been coated with a material that is not allow water to penetrate through it. And then once you are doing some tasks, you have to know, for example, when you are dealing with your household activities, washing of pots, plates and the likes, make sure that you try to reduce the angle of contact to 0. If you are opportune, try to warm the water so that you use a small quantities of detergent rather than using a large one. Okay, so this is what I have today. Next time we meet, we complete the other aspect of it, which is capillarity, viscosity and the like. So I wish you safe staying at home. So till we meet next time, I'm your Malam Abdul Wahid. Assalamu alaikum warahmatullahi wabarakatuh.